Hello and welcome back. The robot controller is the brains of the robot. It uses programs to solve problems and to achieve goals. Robot control is the means by which sensing and action of a robot are coordinated. Robot control can take place in hardware or software. Hardware is good for fast and specialized uses. Software is good for flexible, more general programs. Feedback control is good for low-level control of actuators, such as wall following or obstacle avoidance. More complex controllers are typically implemented in software. Complex tasks require a control architecture, such as localization, object retrieval, mapping, path planning, etc. A robot control architecture provides the guiding principles and constraints for organizing a robot's control system, i.e. brain. Solving a problem using a finite procedure is called an algorithm. You will write algorithms in this course that will be converted to code in order to build the control architecture on your mobile robot. I will request that you use state diagrams, function descriptions, or flowcharts to illustrate your algorithm to help me understand your design process. Here is a high-level summary of the 4 control architectures based upon their primitive organization. Can you identify which graph goes with which architecture? Reactive control is also called don't think, react. It is a tight coupling between sensing and acting with no world model. Behavior-based control is referred to as think the way you act because there are parallel task-achieving behaviors with a distributed world model. Hierarchical or deliberative is also referred to as think hard, act later, because all of the sensing happens first, then the plan, and then the action. It has a very detailed world model that should remain static during plan execution. And hybrid control is also referred to as think and act independently and concurrently, because it has a combination of deliberative and reactive control. The control architectures differ in the way that they handle time, modularity, and representation or space. We've already looked a little bit at modularity or the organization because it's how the sense, the plan, and the act connect together. Now let's talk a little bit more about the time. Time refers to how fast do things happen. Do all components of the controller run at the same speed? Time refers to how fast the robot responds to the environment compared with how quickly it can sense and think. Deliberative control looks into the future, so it works on a long time scale. Reactive control responds to the immediate real-time demands of the environment without looking into the past or the future. Hybrid control combines the long time scale of deliberative control and the short time scale of reactive control. And behavior-based control works to bring the timescales together in a different way than hybrid control. Modularity refers to what are the components of the control system. What can talk to what? Modularity refers to the way the control system is broken into pieces, components, or modules. Modularity also refers to how the modules interact with each other to produce the robot's overall behavior. Deliberative control has a control system with sensing, planning, and acting modules that work in sequence. In reactive control, multiple modules are all active in parallel and can send messages to each other in various ways. In hybrid control, the 3 main modules are the deliberative, reactive, and connection in between. And in behavior-based control, there are more than 3 modules and they work in parallel and talk to each other. Representation. The level of detail in the world model, including the map, belief, self, task, or whether it has one at all, is called representation. Deliberative control has a very detailed representation. Reactive control has no world model, no map, or representation. Hybrid control has a representation for only some tasks. And in behavior-based control, it depends on the behavior. This concludes Lecture 2-1 on robot control. Have a wonderfully awesome robotastic day.